All right, we're getting ready to take a look at 5-2 polynomial division and division algorithm. What we have is really three objectives here: the division algorithm and the remainder theorem. The remainder theorem is pretty cool, so we'll take some time to look at that. Polynomial long division synthetic. We'll look at the differences of the two. Polynomial long division you're somewhat familiar with, hopefully, and it will allow you to divide any polynomial. Synthetic division is much quicker. However, it's some limitations because it has to be, the divisor has to be a specific form. And then constructing polynomials with given zero. So what we're doing is instead of breaking a polynomial down, we are constructing or making it ourselves, right, in the equation. So first off, let's take a look at sort of where the division algorithm comes from. And if you remember some vocab here, let's reference some of it. What we have is we have the q sub x is our function that represents our quotient of a problem. The d sub x, which is our divisor, is what we're dividing by. So in other words, if I write it down here a little bit like a division problem, we have d sub x, and then our result is going to be q sub x. And so the result of that. And then our dividend is what's inside. So that's p sub x. And so this is sort of how it's set up as a division. Now we have a remainder. And we'll talk a little bit about the remainder here when we get to the division algorithm and the setup. But when we have an r sub x left over, what we have is we can represent it. So we'll do some operations here, and we potentially could have a remainder left over, and that remainder is going to be used with the divisor to represent part of our answer. So this is where it comes from. And if you remember to check your answers, if you did the divisor times the quotient, you would get the dividend. And so that's how we could do it with just numerical values, and we'll be able to do it with polynomials as well. One thing to take a look at here, and how do you know if a polynomial is a factor of another polynomial? And so how you know that is if the remainder is 0. If the remainder is 0 of this division problem, you know it goes into it evenly. Think about numbers. How do I know that 3 goes into 12? How do I know that 3 is a factor of 12? Okay, is another way of looking at that. Well, I divide 3 and 12. I go 12 divided by 3, which is 4. And if I do, that numerical long division, I get a remainder of 0. Now think about that. Now I know 3 goes into 12 because we say it goes into it evenly. Well, what does that mean? You get a remainder of 0. So anytime you do division and a value goes into another value without there being a remainder, that value is considered a factor as well as the quotient you receive. So in here, what I mean is 3 is a factor and 4 is also a factor. How do I know? Because there's a remainder of 0. So what this does is it definitely starts leading us a little bit into where we're getting to that remainder theorem, zero remainder theorem, but we'll get to it in just a moment. First things first, let's go ahead and take a look at the division algorithm. So if you go back to the screen that we just had, if you take this and divide everything by d sub x, so I'm going to divide this and this and this, everything by d sub x, the divisor, divide everything by d sub x, then what you get is you get this equation right here, this sort of formula, which is really what we're comfortable or familiar with. What I have is I have the p sub x. Now, if you remember, the p sub x is what's inside. That is the dividend. So the dividend divided by the divisor is equal to the result quotient plus the remainder over the divisor. Okay, now let's see if this makes sense. Let's look at a numerical value, 23 divided by 4. So if I write it right here, 23 divided by 4. So p sub x is our dividend, d sub x is our divisor. 4 goes into 23 5 times. So I put a 5 up here and I multiply these two. So keeping track of what I'm saying here if you don't remember long division. You multiply these two and then you subtract those from each other and then you have 3 and there's nothing else to drop. And so what we do, and there's a few different ways when you first did long division, putting the big R, putting decimals, things like that. But the one way that we're going to use is we're going to take the quotient, that's q sub x right here, q sub x, and then we take the remainder, which is 3. And if you remember, don't we put the remainder over the divisor? So we took the remainder, put it over the divisor, and that represents our solution to this division problem is 5 3/4. 5.75 is what 23 divided by 4 is. And so the question is 4 a factor of 23? No. Okay, now why? Because I got a remainder other than 0. And if I get a remainder other than 0, it's not considered a factor. Neither is 5, because that's both of those are connected to this remainder of 3. And so what we're doing is we're taking one polynomial divided by another one with a smaller degree. And then the result of this is a polynomial plus possibly the addition of a ratio of two other polynomials. In other words, what we have is remainder over divisor. And so in English, what this is just simply long division with the possibility of a remainder at times. Okay? So So let's go ahead and look at the remainder theorem before we get into long division or synthetic. Now the remainder theorem is a pretty neat theorem. What it says is this. If you're dividing, let's say, a polynomial piece of x, and you're dividing it by some other polynomial called x minus k. Well, if I want to know what the remainder is of this, which is going to be pretty important, then what I can do is simply figure out what is k, and I take that value and I can plug it in. The remainder, the value of plugging in k is going to represent the remainder as if I did some type of long division of x minus k. Now, why is that so important? Well, if you plug in k into the function and the result is 0, that means the remainder is 0 in that case. If the remainder is 0, then k is considered a solution. It's an answer. It's a 0. It's a root of that polynomial. That's pretty big. That's where it crosses the x-axis. And it also tells you that x minus k is considered a factor of piece of x. Again, why? Because the remainder is 0. If the remainder is 0, then k is a solution, and x minus k, which notice up here the counterintuition. I want to, note that. So if we had x minus 3, what is our k? K is 3. And if it's x plus 3, it's counterintuitive, so it should be negative 3. So we've talked about counterintuition, so make sure you observe that as you're finding your k's. A lot of times the k is going to be given to you like this example down here. K is 3. So if I want to find the 0 here of, in other words, is k a 0 of this polynomial? The answer is either yes or no. How do I determine that? Well, what that means is that when I plug in 0, plug in 3, my k, I should get 0. And so we go, well, you might need a calculator for this. So what we're going to do is we're going to simply plug in k in for x. And so our k is 3. And so I simply will use my calculator here and determine what all these values are. And so if you have a calculator handy, you might grab it because you'll see that we will have some larger numbers here to deal with. So really quickly, I'm going to go through this and find your answer. 3 to the 4th is 81 times 3 is 243. So our first value is 243. And then what we have here is 3 cubed, which is 27. 27 times 11 is 297. And then we're subtracting here. 3 squared is 9 times 3 is 27. And then we're going to add whatever 34 times 3 is. And 34 times 3 is 102. And then we subtract 21. Now, if I plug all this back into my calculator and figure out, okay, what do I have going on here? What you'll notice is you end up getting 0. So, is 3, which is our k, considered a 0 of the polynomial? Your answer for this one would be yes. If your answer was no, then you would want to put whatever you got. So if you got like negative 4 over here, well, that's your remainder. That's what you're going to get. Now, what else does it tell us other than 3 is a solution? So I know 3 is a 0. It's a root. It's a solution. It's an x-intercept of this crazy-looking polynomial. What else do I know? Well, I also know x minus 3, that polynomial, is a factor of piece of x. How do I know that? Because this is where the 3 came from. This is the polynomial it came from. And when I plugged in 3, here's your remainder theorem. The remainder is 0. And when the remainder is 0, whatever you divided by or whatever you're trying to figure out is considered a factor. So x minus 3 is a factor. That's good to know because now I know one of the factors. So if I'm trying to factor this huge polynomial, I know one of the factors and I can use longer synthetic division to find possibly some others. And that's where we're heading. Okay? So let's talk about those two types of ways of finding our division problems. The two types of division are going to be polynomial long division and polynomial synthetic division. Now, the long division one works for any polynomials. Okay? So there's not a lot of restrictions there. There's some things that you want to be concerned about, but it's going to be able to be utilized at any point for division of polynomials. Now, synthetic division, on the other hand, is a shortcut method, but it has to be in the form x minus k. And what I mean by it is the divisor has to be in the form x minus k. So we can fix it if it's not, unless the degree is not 1. The degree has to be 1. Okay? The degree of the divisor has to be 1. If it's not 1, you can't use synthetic division. You have to use long division. However, if the degree is 1, we can manipulate the rest of it. So in other words, if it's like 2x plus 6 is my divisor, I can divide this as well as my dividend by 2 to get it to be x plus 3. To get into a form that I know what my k is, which is negative 3. but just make sure when we get one like this, if we do, make sure you divide not only divisor, but also the dividend. You're going to divide everything in order to get it in the right form. Well, let's first take a look at long division though. We have some numerical examples up at the top, so let's look at those first. And so I've got 3, and if you remember, we did the one like this just a minute ago, a little bit ago, where what I'm trying to do is make 3 a 12. So I say, what do I multiply 3 by to make it 12? And hopefully you'd say 4. And then we always perform a subtraction. So watch what I'm doing, because we're going to do the same thing down here with the algebraic way of doing it, in other words with polynomials. So we go, this times something gives me 12, and then I bring down that next term and I start over. 3 times what gives me 4? Well, 3 times 1 gives me close to 4, and then I get this, and I get 18 brings down, or 8 brings down and get 18, and then I get a 6. And so what I get is a remainder of 0. Now that tells me a few things. First off, my answer to this, my quotient, is 416, so that's technically my answer. But what does that tell me with the remainder of 0? It tells me that 3 goes into 1248 evenly. In other words, it's a factor of 1248. What else is a factor of 1248? 416. How do I know? Because it's part of 3. 3 times that gives me 1248 with a remainder of 0. And so that, therefore, those two are considered factors of 1248 because the remainder is 0. Well, what's it look like if the remainder is not 0? Well, here's one. I'm going to go a little quicker on this one. And so bring down the 4, and I multiply by 1. And I 17. Now, 3 doesn't go in 17 evenly. And so what I end up getting is I get a remainder of 2. And so there's nothing else to bring down. So how do I write my answer? So what I have is a quotient of 415. Here's your remainder theorem, or excuse me, of your division algorithm. Here's your quotient, 415. My remainder is 2, and then my divisor is 3. So we write it 415 and 2/3. Now what's that tell me about 3 and 1247? What relationship do they have? Well, I can tell you this much. They're not factors. 3 is not a factor of 1247. Neither is 415. How can you justify this? And this is good ways to justify your answers. I can justify it by saying the remainder is not 0. If the remainder is 0, these would be considered factors, like this one over here. However, these are not, the remainder is not 0, so therefore those are not considered factors of 1247. Okay? Now, how do we apply all this to, let's say, more of an algebraic approach, like this example down here? Now, first off, let me precede this with a little bit of information. You want to first place the divisor and dividend in descending order. In other words, you don't want a degree like, you don't want c plus 3c squared minus plus 12. Okay, this degree is larger than the c. We need to go in descending order. So first things first is that we'd want to go ahead and put them in descending order if they're not already. This one is already in descending order. 2, 1, 0, 1, 0. So according to the degrees. And so we're in good shape to go. The process is exactly the same as what we did up here. You're going to multiply a term to get as close to another value as possible. Now, we're going to end up using this idea, or I'm going to use this idea of a big brother. Okay? Now, I'm a little brother, and what I've noticed as a little brother is the decisions in the family for the kids were based mainly on the bigger brother. Okay? And then the younger siblings, being me, we would tag along. We would benefit from whatever that decision is. However, the decision was mainly based upon the older sibling. So we're going to use that idea here, and hopefully it makes sense to you. I'll show you in just a moment. Then what we're going to do is subtract those quantities, just like we did here. We subtracted, and we subtracted over here. Now, when we do subtraction, you want to be very careful because we're subtracting quantities instead of just one single term. So we need to make sure to distribute a negative through. So you either need to place parentheses around the quantity, or I'll give you some other suggestions. You can change the signs of each being subtracted, or even a third one is you can put a little bubble around the subtraction sign just to hopefully remind you that you're subtracting an entire quantity. So whatever you feel works best for you, you want to go with and stick with. All those would be good options. Then we're going to bring down the next term, and then we'll repeat the process. Here's a key thing down here at the bottom you want to make sure to note. And that says, look, you want to insert zeros, or 0x's, or 0x squares, or for any missing degrees. And so let me give you an example. If I gave you c cubed plus c minus 7, do you notice I went from a degree of 3 all the way to a degree of 1? I'm missing the degree of 2. I jumped over it. Well, when we write this in long division, a lot of times we'll need that c squared, which means that I need to go ahead and add in how many c squares do I have? Well, 0 of them. Okay? And that's the exact same expression. The difference is now I account for all the degrees. Definitely in synthetic, you have to do it. With long division, sometimes you can get away with not, but I encourage you to start right now by identifying any degrees that are missing and then replacing them with zeros. And if you don't need them, you don't need them. Sometimes you skip over them when you do the problem, but in most cases you'll want to have them. So let's just go ahead and get in the habit of doing that. Let's look at this example here. I'm going to write it as a long division problem. So instead of as a fraction, we'll write it as a long division. Now let me show you what the big brother is now. The big brother is going to be this C right here. That's what I'm going to call the big brother. So all the decisions are going to be based on that C. The -4 is going to be the younger sibling or the little brother. It's going to tag along after the decision has been made. However, the C is what the decisions are always going to be based on. So this is what I mean by a decision. C squared is my first term over here. I want C to be C squared. So the question is, what would I multiply C by to make it C squared? Much like what would I multiply 3 by to make it 12? And you would say, hopefully, C. So C times C is C squared. Now your tag along, -4C. And you'd stack everything and look how everything looks nice. Now this is where you have decision. You either need to put parentheses around with subtraction sign out front to recognize that we're going to distribute or subtract that entire quantity. That's an option for you. You can also put a negative with a bubble around it. You just got to come over here every time. So if that's something that you feel comfortable doing. A lot of students have started to just change the signs of the terms down here in the red. And so this becomes negative and this would become positive. And that way you don't have to remember necessarily to distribute. It's already done for you. So once you get your multiplication done, you can change the signs. And what that allows you now to do is simply add these two. C squared minus C squared is 0, goes away, and that's what needs to happen. -7C plus 4C is -3C. Okay? And so make sure you can get to -3C. Now we bring down the next term. That's where we're at, bring down. And so we get a plus 12. And now it's like starting over. I go and reflect on my big brother and say, I need C to be -3C. So what would I multiply C by to make it -3C? Well, -3. And you get -3C plus 12 because the tag along little brother is still there. Again, what you might want to do is you might want to go ahead and change the signs of everything. And so that this one becomes positive, that one becomes negative. And so this one becomes positive, that one becomes negative. And as you go ahead and combine these, those cancel. And look at this. Those cancel as well. There's nothing to bring down. So my remainder is 0. I bet that tells me something. But let's go back and talk about our answer. First off, our answer is simply C minus 3. That is our quotient, is what we have. So that's technically the answer. However, what else does it tell us when the remainder is 0? It tells me that C minus 4 is a factor of C squared minus 7C plus 12. It also tells me C minus 3 is a factor. Now think about this. If you would factor that trinomial, wouldn't we get to C minus 4 and C minus 3? Factors of 12 that add up to -7. So notice how long division verifies our factoring that we've done, creating bubbles. And so if it goes into it evenly, those are considered factors. Those are bubbles and allows us to sometimes actually factor out very complicated polynomials. This one wasn't that complicated to factor out. Let's take a look at one that would be very complicated to factor out if we had to. One like this one. Now notice our dividend is this giganto, 6-termed polynomial, and then our divisor is not a small thing. It's a 3-term polynomial. And so what we want to do here is we want to go ahead and just step by step go through exactly the same process. So here's my big brother. Put the box around it. And I want to ask it questions every time. So my first question is, I want to make 9x squared 9x to the 5th. So the 9's are already the same, so I don't have to do anything there. But x squared, to make it x to the 5th, wouldn't I cube that? Because multiplying powers, you add exponents. So you end up getting 9x to the 5th. Now the tag-alongs. I get -1 times 1, which is -1. X times x cubes x to the 4th. So we get to there. Then -1 times 1 is -1. And then I get x cubed. Do you see how the degrees are sort of stacked real nicely? Now this is where you might want to change signs, or you can put a negative out there, however you want to do it. I'm going to change signs of everything. And now I can simply just go ahead and add these. And so those cancel. And that's how it always is going to be. Now notice what we have. -10 plus 1. Last names don't change. So -10 plus 1 is -9. Last name stays the same. Here I have 18 plus 1, which is 19 x cubed. And if you remember, what we do next is bring down the next term. And now it's like starting over. And so I go ahead and I proceed with the the big brother, and say, what would I multiply 9x squared by to make it negative 9x to the fourth? Well, how do I make 9 negative 9? Well, negative 1, right? So I'll put that. The 1 probably will come here, is just going to be invisible. How do I make x squared x to the fourth? Well, it's another x squared. Multiplying powers, you add exponents. So negative 1 times 9 is negative 9. X squared times x squared is x to the fourth. So there we go. Now the tag along, little brother. So negative times negative is positive. X squared times x is x cubed. Negative times negative is positive. X squared times 1 is x squared. I draw my line, and now I can go ahead and execute my subtraction. Now, for some of you, it may be changing the sign. So I'm going to go ahead and change the signs of these. So these two are going to become subtraction. Okay. And really, the reason I'm changing signs is because we're subtracting the entire bubble. And so when you subtract a bubble, you distribute a negative through, you change the sign. So here we go ahead and we cancel, and we see what we have left with it. That's gone. We have 19 minus 1, which is 18x cubed. We have negative 28 minus 1. So that's negative 29x squared. And then we bring down the next term and we start over. So you can see how it sort of takes a long time, hence the name long division. And then we just, okay, well, big brother, 9x squared. How do I make it 18x cubed? Well, how do you make 9 and 18? Multiply it by a positive 2. How do you make x squared x cubed? Well, you need an x. So that's where I get my 18x cubed. Tag-alongs, I get negative 2x squared. And then I get a negative 2x. I'm going to change the signs or perform subtraction. So either way. And so these are going to cancel. I'm going to go a little quicker at this point. Negative 27x squared. And then I get positive, that's a square, and then plus 3x. I bring down the 3 all the way. I'm running a little out of room at the bottom, but hopefully we can finish this off. I may bring it up here for you to see. So negative 27x squared plus 3x plus 3 is where we're at. So my big brother is 9x squared. How do I make it negative 27x squared? Well, what do I multiply 9 by to make it negative 27? Well, hopefully you said negative 3. And so what I get is I get negative 27x squared when I multiply those two. Negative 3 times negative 1 is a positive 3x. And negative 3 times negative 1 is positive. Look at this. Okay, and then if you change the signs, everything's going to cancel out. That's the beauty of some of these problems. So here we go. That becomes a plus sign. This is actually going to become a minus sign. This is going to become a minus sign. And notice that everything's opposite signs. You get a remainder of 0. So the solution to this, here's your quotient. That's answering the question. Divide those two. We did. There's our quotient. My next question is this. What does that tell you now about the divisor, 9x squared minus x minus 1, and about the quotient, x cubed minus x squared plus 2x minus 3? Well, what it tells you is this is a factor, and this is also a factor because we got a remainder of 0. And so now I can break this down into two bubbles. I know they're still sort of big, but man, are they a lot more manageable than this big 6-term. Is now we have this trinomial times this 4-term would represent my piece of x or my dividend. Okay? Let's take a look at another one. Now, the directions, if you notice up here, it says use polynomial long division to rewrite the following fraction in the form q sub x plus r sub x over d. In other words, they want you to use long division, and if there is a remainder, they want to put the remainder over the divisor, is what they're saying there. So don't read any more into it. Let's take a look at it, and again, we'll go fairly quickly. I would recommend you maybe pausing it here and trying it out yourself real quick. And if you get stuck, that's all right. Play the video and see if I can't help you out. Now notice we're missing a constant. Now we could add in a 0, and with synthetic division you would. With long division, what we'll notice is we don't necessarily need it because all you're doing is bringing down a 0, which doesn't change anything. So we should be in pretty good shape just as it is. Okay, but this is where we're at. Okay. Now what I want to do is I'm going to put a box around my big brother that I'm going to reference. And now I'm going to go ahead and start the long division process. Okay, so this would be a good time probably to pause it if you want to try it on your own, because I'm going to go fairly quickly through. So here we go. Okay, I need a 5. I need an x squared to make that 10x to the 5th. Okay, I did my tag along little brother, negative 5x cubed. Now, now notice notice we get 5x squared times x is negative 5x cubed. I can't put it here because it's not an x to the 4th, so I have to slide it down and put it right there, because I want to stack all like terms. So really, what do I have right here? Well, technically, we have 0x to the 4th is what we have. So So I'm going to subtract. I'm not going to change signs on this one. I'm going to show you the way by putting just a subtraction sign over there. But make sure you subtract. Don't go straight up and down. You got to always come over here. So 10 minus 10 is 0. 2 minus 0 is 2. So that's how that works. Negative 9 minus a negative 5. Negative 9 plus 5 is negative 4x cubed. And then I can bring down my next term. So you can see where we skipped over one to keep everything really stacked nicely. Now let's go ahead and start over again. So I need 2x cubed to be 2x squared. I just needs an x, doesn't it? And so I need 2x to the 4th minus x squared. I got to skip that one and go over here. So minus x squared. I subtract. So these are gone. Negative 4 minus 0 is negative 4. And oh, look what happens here. Don't these go away as well? And so I can drop down my positive 2x. So things get a little bit spaced out, but that's okay. We should be in pretty good shape at this point. And so now what we want to do is we want to go ahead and proceed with multiplying by our big brother to make 2x cubed negative 4x cubed, so negative 2. So we get negative 4x cubed, and then we get a positive 2. Oh, man. Okay, and then you subtract. Look at that. Those cancel. 2 minus 2 goes to 0. That's a beauty. We haven't had a remainder yet, but what we have had is now this is our quotient. 5x squared plus x minus 2. Our remainder is 0, which means 2x cubed minus x is a factor, and so is 5x squared plus x minus 2 is also a factor. So I could write this crazy looking polynomial as that little bubble times that bigger bubble. Okay, 2x cubed minus x and 5x squared plus x minus 2. Those two being multiplied would give us that. That's in red. That's pretty cool. That's pretty neat. If you take a look at the bottom one, now I'm going to go ahead and erase actually what I'm going to do is I'm just going to copy and paste this to another screen here. I think that may be a better way of doing it. So let's do that. We'll insert another page, and that way we can keep that up there if we need to reference it. So let's go ahead and take a look at this one. Now notice the difference. This one gets a little bit tougher because now you all of a sudden throw complex numbers into the mix a little bit. Setup's no different. Execution's no different. We just got some arithmetic we want to be extra careful of, and we need to know how to handle i's. And so remember I squareds and things like that. So here's our dividend. Here's our divisor. And now we're going to go ahead and execute. Again, this would be a good time. If you want to try this on your own before I even get started, you can. This one's going to be a little tougher, so I can understand you sort of watching this one. But let's go ahead. I'm going to put a box around my big brother. And then I need to go, okay, 7x, how do I make it 7x cubed? Well, I multiply by x squared. Okay, so I get 7x cubed. And then what I get is 6i x squared. Okay, so that's going to match up really nicely there. And so if I subtract, now this one I'm going to go ahead and change my signs. So we can practice doing that one. So I'm going to make that one negative and that one's negative. So straight up and down, that cancels. Straight up and down, look at that, that cancels. So I bring down 28x. Now I'll probably end up bringing down the 24i here in just a moment. But let's just stop right now and make the big brother 28x. And see, oh, I need a 4. And so I need a positive 4 here, and that makes 28x. And now you can see that's 24i, right? And so that's why I would need this one to come down as well. So I bring it down. Now everything matches. I'm going to change signs again. And you can see hopefully that this one also works out really nicely. Cancels, cancels, and a remainder of 0. Now again, what does that mean? My quotient is x squared plus 4. My factors are 7x plus 6i and x squared plus 4 of that red polynomial is what it is. Okay. Now, what you've noticed here is that we haven't really had any where there is a remainder. And so maybe it's a good thing to take a look at a remainder. So let me write one up here and take a look at, we'll just look at a basic one. So let's go x squared plus 3x plus 5. And let's divide this by x plus 1. Okay? So x plus 1 doesn't go into x squared plus 3x plus 5 evenly. So we should hopefully come out. So here's our big brother, and we go, well, I need to multiply x. So we get x squared, and then I get positive x. I'm going to put a bubble around it this time so we can look at all the methods. So x squared minus x squared, those are gone. 3x minus x is 2x. And then I bring down the 5. So I start over. What do I multiply x by to make it 2x? Well, positive 2, right? So I get 2x plus 2. And then again, I would put a bubble and subtract, and those would be gone, and I'd end up getting 3. There's nothing else to bring down. Okay, let's watch this. Okay, so my remainder is 3. So my quotient is x plus 2. My remainder is 3. So you're going to add in the remainder over what you divided by, which was x plus 1. So notice what we have is we have quotient, and then we're going to add in the remainder over the divisor. Right? And that's how we'd end up putting our answer for that problem right there. X plus 2 plus, and there's a part. So it's a whole plus a part equals that. And so if you get something like that, that would be a basic example of how you would handle the remainder being left behind. If it was a negative 3, okay, let's say you had a remainder of negative 3, then you would add in a negative 3. Oops, that was ugly. You would add in a negative 3 over an x plus 1. There may be a better way of writing that when you add a negative. Isn't that the same thing as subtracting? And so you could write that 3 on top and put the minus sign there in front. So either of those would be appropriate if that was a negative 3. Right? Okay, let's move on to synthetic division because we've got to sort of move on. We're already a good 30 minutes in. So let's take a look at synthetic division, which is a shortened version of the polynomial long division. It can be used when the divisor is in the form x minus k. It has to be in the form x minus k, or you cannot do synthetic division. It has to be a degree of 1. And then you want to be able to recognize what your k is, which again is counterintuitive. And so make sure you're identifying what that k is. Synthetic division does not do anything that long division can do. Actually, long division actually does more. It just takes a little longer. But synthetic division is so much quicker that it's so good to use, especially when we can. And so we take away the variables with synthetic and just deal with the numbers, which is usually what students like. They just want the numerical values and not necessarily the variables. Okay? Now, how do you set up a synthetic division problem? Now, get this in your notes. I'm going to go through very quickly, and then we'll look at a problem. So looking at a problem makes all this information look better. It's hard to understand what it looks like just looking at these words. But step 1 is write k and the coefficients of the dividend. Copy the leading coefficients of the dividend in the first slot below the horizontal line. So in other words, it's going to look like this. I know it's going to look weird. But you're going to find your k, and you're going to put your k in a half box, okay, in the upper left-hand corner. Then you're going to put all your coefficients. Okay? Remember, it needs to be in descending order, not leaving out any degrees. So if you're missing a degree, what do we put in as this coefficient? 0. Okay? So make sure you're looking going, okay, if I have c cubed plus 3c plus 5, my coefficients are 1. And then notice I'm missing a c squared. So 0, 3, and a 5. 1, 0, 3, 5. So we would write in whatever our coefficients are right next to the box horizontally. And then we'll have sort of some space here, and we'll draw a line. So it looks like this. And then right below your last C will be another half box. Okay, so that's sort of the setup. That's the template you would want to utilize to set up your long division. Then there's sort of a process. What we want to do is we want to go ahead and drop the first value, the first coefficient down below that horizontal line. Now once you drop it, now you multiply by k, multiply that number by k, and write it into the next open spot. So you're going to take this k and multiply, let's call that c sub 1, by c sub 1. And you're going to add it to that spot right there. Okay? And so now what we have is we're going to add those two, and we'd end up getting another number right here. Well, anytime you drop a number below that horizontal line, you're going to multiply it times k and add it to the next open spot. And so that is your pattern. Is you multiply, add, multiply, add, multiply, add. Whatever falls inside this bottom box, the last one, is considered your remainder. Okay, that's what goes into that half box right there. So you're going to repeat that process over and over. Okay. The last step is once we do that, we can write our quotient, which is going to be 1 degree less than what our dividend was. So if you started with a dividend of x cubed, your result's going to start with x squared. And so it's always 1 degree less. Now let's look at an example. We're not even going to look at the polynomials. All I'm going to do is just look at the process of synthetic division. In this case, k is 2. Okay, what we call k. So where did it come from? Probably x minus k is what we divided by. What is this? Well, this is our constant. Okay. This would be our, let's say, x, our linear term. This is our x squared. This is our x cubed. And so this would be sort of like the dividend. So that's where it came from. This divided by that. We found our k. We wrote all of our coefficients, not missing any. Now here's the process. You drop, multiply, add. Multiply, add. Once you dropped, okay, this one drops, don't you multiply and then add. So we're going to multiply 2 times 4, and then we're going to add that to the next open spot. You don't have to put these arrows when you do it, I'm just showing you. Okay, and so we get 2 times 4, which is 8, and we end up getting negative 1. We just dropped it, so what do? Negative 1 times 2, always times our k, you get negative 2. And so what we do is we go ahead and add, and we get 5. Now, let's see what this says. First off, the 5 is your remainder, okay, which means that x minus 2 is not a factor of this polynomial, it doesn't go into it evenly. But if we want to write our answer, notice we started with a cubed in our dividend. Then that means that this must be an x squared, this is our x, and this is our constant. It's always 1 degree less. So if I rewrote my answer, what is my quotient? What is the actual answer here? Negative 2x squared, positive 4x, a negative 1, and then we have a remainder. Now notice it's positive 5, and what do we put that 5 over? We put the remainder over the divisor, and the divisor in this case, even though it wasn't given to us, we found it, was x minus 2. Technically, this would have been your answer for that synthetic division problem, okay, with a remainder. Okay, let's move on. Because synthetic division is much faster, it's very useful to determine if it's a factor or something. So in other words, if I want to know something's a factor, we can either use the remainder theorem, which is just plugging in our k, and then that will help us determine whether or not a remainder is 0 or not, because that's going to tell if it's a factor. Or you can simply use synthetic division because it's so fast. Sometimes it's faster than plugging and chugging. And so that's going to be an option for you. And so p sub k is the remainder using synthetic division. And so what we want to do is we want to look at a problem like this. Now, we could simply plug in negative 5. That's what we did earlier, determine if it's a 0 or not. However, what that does is it still limits us into writing it just as it is a 0 or not. It doesn't allow us to construct the factors, only one factor. And so the second one needs to come from something else, so synthetic division. So here's your setup. I went ahead and covered it up, so that way you can pause and see if you got the right setup. And so if you do the setup, negative 5 is our k. They just flat out give it to you. Now where does that come from? It comes from x plus 5. That's not given to you, but that's actually where it came from. It's counterintuitive. That's where our k is. So we know we're dividing by x plus 5. Now, this is what we're dividing into. This is our dividend, 2x to the 8th. Now, are we missing any degrees? Yes. 6, 5, and 3. We're missing 3 degrees. Whenever I'm missing a degree, I need to add in a 0. So we start with 2, because that's our first coefficient. Then we go 10. Then don't we go 0, and then 0, then negative 1, because that's a negative 1 in front of the x to the 4th. And then a 0 because we're missing x cubed, and then 25, and then what? 1, and then the last one is negative 3. And so what we get is we get that setup for our synthetic. Now watch how fast this goes once you get the routine down. We drop the first term. Okay? So the first term is dropped. Then you multiply, add all the rest of the way through. Okay, so here it goes. Negative 5 times 2 is negative 10. That's 0. What's negative 5 times 0? Because we just dropped it. 0. We add. 0. What's negative 5 times 0? 0. 0. We add. Negative 5 times 0. 0. We add. We get negative 1. What's negative 1 times negative 5? Well, it's 5. So I add it in. It's 5. Negative 5 times 5 is negative 25. What's 25 plus a negative 25? 0. What's negative 5 times 0? 0. So before I finish this, are you seeing the pattern? K times whatever we dropped. Add it to the next open spot. Multiply here. Add it to the next open spot. Multiply here. Add it. Multiply, add. Multiply, add. Multiply, add. Multiply, add. And then the very last one we get negative 5. Remember we have this last box. We get negative 8. Now, the question is K a 0? We did all that work. Is K a 0? No. Well, how do I know that? How could I justify it? The remainder is negative 8 and not 0. If the remainder is 0, that would make it a factor. That would make k a 0, and it would make x plus k a factor. Okay? And so in this problem, I could tell you right now, no. And that's probably faster than plugging it in, to be honest with you. Yeah, it may be relative, but once you get good at the synthetic, that's going to be very quick. And again, all we're looking for is the remainder. That's all we really care about. So what is p sub negative 5? it would be -8. And that's your remainder theorem. Whatever we plug in, the remainder tells us what the value is when we plug it in. Okay? All right, let's take a look at another one. This one, this says determine if k is a 0. If not, tell me what it is. So that's what we did on the last problem. So this one I covered up everything. So now the first thing is what goes in our half box. Well, it should be our k. Now they just flat out give you the k, but where does it come from? It came from x minus 4. It's counterintuitive. That's where it came from, but we should have put a 4 right there. Now we do coefficients, not missing any. 3, 2, 1, 0. Got them all. 2, -1, -25, -12 is where we're at. Now the pattern. Okay, so our pattern is going to go drop the first one, multiply, add, multiply, add, multiply, add. So 4 times 2 is 8, add it. So we end up getting 7. So then I do 4 times 7, which is 28. So I get 3. Then I do 4 times 3, which is 12. And look what we get. 0 is a remainder. So the question is k a 0? Yes, it is a 0. How do I know? The remainder is 0. Now, what are my bubbles? Okay, well, x minus 4 is what we divided by. And what do I have left? Well, it's always 1 degree less than what my dividend is. So this is going to be an x squared. This will be an x, and this is my constant. So 2x squared and a positive 7x and a positive 3. This would be my factors. My answer, though, is yes, these are, this is a 0. 4 is a 0. You could plug that one in. That wouldn't have been that bad. But I wanted to show you how it would work using synthetic division. Okay? Let's look at this. It says use synthetic division let me move it's right here, to determine if the given value for k is a 0. So same kind of thing, but notice this is a complex or imaginary solution. So our k is now -5i. Our coefficients are 2. Be careful here. Our coefficient, the bubble, see what's in front of the x is the bubble, but notice there's a negative sign. So my coefficient is actually that distributed. And so what I get is I get -3 and a positive 7i. Ooh, that's tricky. Make sure to get that one written down. And then here I don't need to worry much because there's a positive, but I get 15 minus 15i as my constant. Okay, draw a line, and then there's my half bubble. So I have really 3 terms up here. They're sort of grouped a little bit together, but we should be okay. The process goes like this: drop and multiply. I get -10i. So I put -10i. I just stack it. It's like having the real parts being 0. Okay, you can put a 0 there if you want, but you don't need it. But we're going to add these together. So I get -3 as my real part, and I get -3i as my imaginary part for that complex number. Now what I can do is I can take -5i and multiply it by -3, which is positive 15i. Okay, so -3 times -5i is positive 15i. That's where I got that. And then I do -3i times -5i, which is 15i squared. Okay, here we go. What is I squared? -1. What's 15 times -1? -15. You can see it coming in, so we're going to put -15 right there. It's a real part. And now what we have is now we're going to go ahead and add these two together. 15 minus 15 is 0. Those are gone. And those are gone. We get 0 as a remainder. Okay, so the question is k as a 0 of this? Absolutely. This is a 0 of that. Much easier than maybe plugging it back in is using synthetic division. Not easy, but maybe it's easier. Now, what else do we know is that x plus 5i is a factor, because that's where this comes from. But also, 1 degree less is 2x. And then you can put a negative in bubble if you want as your constant, or you can put it as negative, or you can write it as this. And that would have been fine as well. I like this top one better. But these two right here would be considered our factors. Or this one and the top one would be the same thing. So if they're asking about factors, those would be the 2 factors of that polynomial. Okay? All right. Let's do a complex long division. And notice on this one I added one in where there's a 0x. So we haven't seen one too much, but here I had a 0x here. But we have an imaginary or complex value that we're dividing by. Here's your big brother. Let's roll. So I'm going to go fairly quickly on this one. Pause it and you try it yourself. I think you can do this one without me assisting you right now. Okay, go x, you get x squared, and then you get plus x, ix. Okay, because I had to multiply there. So I go ahead and subtract, and so these are gone. 0 minus this is negative ix. And then I bring down the 1. So I start over. How do I make x negative ix? Well, negative I. Okay, so I get negative ix, And then I get negative I squared. Okay, negative I squared, isn't I squared negative 1? So I get the opposite of negative 1, which is a positive 1. Go ahead and subtract everything there. That's gone. That one's gone. I get a remainder of 0. And so what I get is my quotient is x minus I. If you FOIL these, doesn't it make sense? X minus I times x plus I. These are conjugates. So you get first and last, all you have to do. And then what's I squared? Positive 1. Negative 1. And so what you get is the opposite of negative 1, which is positive 1. We get back to our dividend, x squared plus 1. Okay. Now, synthetic division. We've already looked at one like this. I'm actually going to move on a little bit, but this is a good one to take a look at. Here's your answer. So when you're done taking a look at it, now you can look at the answer. So if you want me to cover it back up, now you can work it, maybe pause it and rework it, and then just make sure to check your answer there. And if you have any questions, let me know. Let's get to constructing polynomials. We know that the connection between zeros and factors now. If k is a 0, then x minus k is a factor. I've been talking about that the whole time in hopes that it's starting to sink in. Now what we can do is we can start constructing polynomials using that knowledge. And so there's two different types that we're going to look at here in our practice. We're going to look at them giving us zeros in behavior and then zeros in the y-intercept. It could be zeros and another point, and that would be like the y-intercept. So that falls into that category when we get to it. But we want to construct a polynomial that has the given properties, third degree, okay, which just means it's going to be an x cubed, and it goes from negative infinity, goes to negative infinity as x approaches infinity. So it talks a little bit about our in behavior. So it's a third degree, which means it's a ziggy. That's why. And if it goes to negative infinity as x approaches infinity, it would be a backwards. It would be a reflected ziggy. Okay. And if it's a reflected ziggy, that means that our value of a is going to be negative. So we'll talk all about that in just a moment. But first off, let's go ahead and construct this polynomial. I'm going to call it piece of x. It's going to look like this. It's going to be sort of like in an intercept form. And you're going to have your roots. And I'm going to call your roots, in this case, P and K, and maybe in this case, H as well. And those are your roots. They tell you the roots, the zeros, negative 4, 6, and 1. That would represent your P, K, and H. If they only give you 2 of them, that would just be P and K. You wouldn't have this last one then. And so that would be where we start, is in this intercept form that shows us the x-intercepts. So we would have a situation like this, where I would plug in negative 4, so that makes it x plus 4, and then x minus 6, and x minus 1. Okay, so that's where we're at. We're almost there. All we need to know is A. Okay, that's what the in behavior is going to tell us. We just mentioned it. If the in behavior tells us, okay, first off, it's a ziggy. If it's a normal ziggy, my A would have been positive. But because I've reflected it over the x-axis, that tells me my A must be negative. Therefore, what I want to do is just make a negative 1, because there's no other information given to you. So we don't know if there's any stretches or compresses. All we know is that that meets that condition. And so there is our newly constructed function. Okay, we have our intercepts, and this right here, the A value is either going to be used as a point or as like a y-intercept, or it's going to tell us it's in behavior, and that's what we have here, is it's in behavior. So let's take a look at a y-intercept one. So this is where a y-intercept or point, okay, is a good way of doing this one. Okay, construct a polynomial that has the given properties, fourth degree. Okay, that means it's a parabola, right? Fourth degree looks like this or this, depending on its in behavior. But we do know it's zeros. It's right here, and 6. So we know those 4 things. And the y-intercept is 108. Now remember, the y-intercept isn't the constant of any polynomial equal the y-int, if you remember that. And so our constant has to be 108. That's interesting. And so I'll show you why that's interesting in just a moment. Let's go ahead and construct this in intercept form. And so here's your intercept form. We got A, and then you can see our zeros, x minus 1, x minus 3, and x plus 3, and x minus 6. So that's where we're at currently. Now, if our y-intercept is 108, that means, okay, to find the y-intercept, the constant, which means all these other things, all the x values have to be 0. Okay? So what we want to do, and you might just jot this in your notes, is plug in 0 for x, and piece of x, which is our y value, should equal 108. Think about it. How do you find the y-intercept? You plug in 0 or how do you find the y-intercept? You plug in 0 for x and you solve. Okay? And so that's what we're doing here. We're going to plug in 0. So 0 minus a negative 1 is negative 1. 0 minus 3, or excuse me, 0 minus 1 is negative 1. 0 minus 3 is negative 3. 0 plus 3 is 3. 0 minus 6 is negative 6. Now what I can do is multiply this. This is going to be 108 because that should be my answer. When I plug in 0, I should get 108. So I should get 108. Negative 1 times negative 3 is 3. 3 times 3 is 9. 9 times negative 6 is negative 54. Now simply divide both sides by negative 54, and you get your a as negative 2. Now what do you think we should do with it now? Remember, what we're trying to do is write this one just without a. Either make it negative, or in this case, we actually know its actual value is negative 2. So we're going to go take this negative 2 right here and bring it right back up, boom, right there, and slap it in. And then what you'll notice is there is our newly constructed polynomial, okay, with that value. Now, if it's a given point, if they say, oh, instead of a y-intercept, let's say it goes through the point 2, 3, I think that's what you do. You plug in 2 for x. You make your piece of x 3. So instead of 108, you'd make that 3. Instead of x being 0, you put a 2 in here, and then you can solve for a and then back substitute in that a. So that would be the same thing as they give you some other random point. It doesn't have to be the y-intercept. Okay? That is 5.2 polynomial division. Best of luck to you.